table of values below may be used to assist you in answering part B of the question. Well, let's do part A. So first of all, we want to differentiate this, and it's a product. So u is equal to x, v is equal to sine pi x over 4. du dx, therefore, is equal to 1. dv dx, well, when we differentiate sine, it goes to cos. So we're going to get pi x over 4 in here because the argument never changes. That's the thing inside the function. But we know we have to use the chain rule here, and the differential at the inside is pi by 4. So the differential is now v du dx, so it's going to be sine pi x on 4 plus u dv dx, so that's going to be pi x on 4 cos pi x on 4. And show that pi x over 4 cos pi x over 4 dx is x sine pi x on 4 plus 4 over pi cos pi x on 4 plus a constant. Now the last part of the question left us with d dx of x sine pi x on 4 being equal to sine pi x on 4 plus pi x on 4 cos pi x on 4. That means that pi x on 4 cos pi x on 4 would be equal to d dx of x sine pi x on 4 take away sine pi x on 4. So the integral of pi x on 4 cos pi x on 4 dx, so that's that bit, would be equal to, if we integrate this, we just get x sine pi x on 4, which is that bit. And then if we integrate sine, we get negative cos, so that will become a plus cos pi x on 4 using reverse chain divided by pi by 4. Don't forget to add a constant. And then that becomes x sine pi x over 4. Here we're dividing by a fraction, flip upside down and multiply, and we get 4 over pi cos pi x on 4 plus a constant. The time in minutes, t, between incoming phone calls at a call center is a random variable with probability density function given here. Determine the probability that the time between two consecutive phone calls is less than 40 seconds. And since this is in minutes, that's 2/3 of a minute. State your answer exactly. So we want the probability of time being less than 2/3. So for a continuous random variable, that's an integral. It's going to be the integral from 0 to 2/3 of pi by 4 cos pi t by 4 dt. That's going to be equal to, remember, cos is going to integrate to sine, and so we'll get sine pi t on 4 divided by the differential of the inside function, which would cancel with the pi by 4 in front. So we're just going to get sine pi t by 4 evaluated from 0 to 2/3. The sine of 0 is 0, so we only have to worry about the 2/3. So that's going to be the sine of 2/3 pi divided by 4. So that's going to be 2/12, which is 1/6. So it's sine pi by 6, which is equal to 1/2. Use the result from part A2 to determine the expected time between consecutive phone calls. The expectation of t for a continuous random variable will be the integral over all values of t of t times this. In other words, pi t over 4 cos pi t over 4 dt. Now, from the first part of the question, we know the value, or we know the expression for the integral, and that is going to be t sine pi t by 4 plus 4 over pi cos pi t by 4 evaluated from 0 to 2. So if we use the 2 in here, we have 2 sine pi by 2. Then we have 4 over pi cos pi by 2. Then take away when it's 0, and of course this part here will be 0 because of the t in front. So it's just going to be the 4 over pi cos 0. Cos of 0 is 1. Cos of pi by 2 is 0, so this part is 0. Sine of pi by 2 is 1, so it's going to be 2 take away 4 over pi.